Hi again, this is Bill Punch from Michigan State University. This is another video on the topic, the practice of computing using Python, CSE 231. Today we want to talk explicitly about some of the odd things that can happen when you pass a mutable argument to a function. Let's go ahead and get started. We pretty much know how this works. We remember this picture. When we pass a value from the main namespace, myInt, to the function namespace anInt, both myInt from the namespace in the main and anInt from the function start out pointing to the same value, 25, which is great. If we were to update anInt inside the function to point to a new object, 37, then that pointer changes, now points to 37. We can't change this object, the object 25, it's immutable. What happens though when we pass a mutable? Let's take a look. Here's another setup. Here is a list, mylist, with the values 1, 2, 3. Mylist is passed to alist. Both elements, mylist from the main, alist from the function, point to the same object, the list 1, 2, 3. But here's what's different. If I make a change, and the important phrase here is in place, and I change an actual value of a list, I take the first value and replace it with the value 100, because this points to the same object as this. When I print my list in the main function, this change will occur. So changes that occur in place on a past mutable value will be reflected in the calling namespace. There are reasons why that's a good thing to do. If we don't want to pass big lists around, we can just use this reference, but we need to know that that in fact happens. The best way to do this is to do some experiments. Let's go ahead and do some. So here's a function, fun1, does exactly what that figure shows. So here's a list 1, 2, 3, my list passed to a list. They both point to the same object. We append to the end of it, and then we print the value in the function and print the value in the caller. And as we said, when we do that, right, both the function has the append as well as the caller, even though we didn't return a list or do anything with that list, right? And that was the reason we showed it in the figure. So, experiment number 2, pretty much the same code with a couple of changes. My list is 1, 2, 3, passed to a list, both point to the same object, but here's an update. Just like we did in that first example with integers, we create a brand new object, even though it has the same values, a new object, and append to that object. Because a list, which did point to this object, now points to a brand new object. That new append does not affect the caller. We get the kind of results that we expect. Right? Change does occur in the function, and we see the append, but because it appended to a new object created in the local function namespace, it doesn't show up in the calling function. Here's a third experiment, and this is a particularly nasty one. Let's take a look at it. My list passing to a list. We do the append just like we did before, changing the same object, but after we're done, we assign the return value back to a list. And what does almost every list method return as a value? None. So we update the list. The only thing that maintains the pointer to that list is my list, and a list gets updated to none. So if I were to evaluate this, in the function none. That's really ugly. Not at all what we want. Here's a picture that reflects that problem. Right? We do everything on the right-hand side first, and we do the append. And having done the append, we then take the resulting value and assign it to the left-hand side, param, which gets updated to none. Two things. If you update in place a mutable that you pass, that change will be reflected in the caller. Secondly, even though we do this in strings all the time, you do not want to assign the result of a method, list method, to anything, because the answer will almost always be none. Last, here is a question. It's strange what happens if you set a default value on a function's parameter to a mutable. Here is an example of that. So here param1 is set to the empty list as a default value, param2 to 27. We do a couple of different calls. All we're going to do is append param2, the second value, onto the end of the list. Pass in 1, 2, 3, 4, append 4, we get an extra value. Pass in that same list, which is now length 5, do an append again. This time it takes the default 27, but what's strange is what happens with all defaults. So let's take a look. When we call this the first time, we have the empty list, param 27, that gets appended, we get the result we want, but at the second time we call it with no arguments, we get two 27s, two appends. What happened? Here's what happened. It turns out that when the default arg it is created only once, and it's created only at the time the function is created. Right? It is not created every time, not created every time the function is called. So if any change is made to the default argument, those changes accumulate, which is really not what you want. So the idea is that it's really never a very good idea to use a mutable as a default. There's a way around it, and this is what you would do instead. You would provide, if you do not get a value, a default value of none. And then you would check in the code if that default value was none, then you would set that parameter to the empty list. What's different is that this code is run every time the function is run and a new object is created, and it avoids the problem. So when we run this, we get the results we expect.